Hello, this is Mrs. Decker, and this is Objective 3A. I can accurately write an equilibrium expression when given a balanced chemical equation. Okay, so first we want to talk about what the equilibrium constant is. The equilibrium constant compares the concentration of the reactants to the concentration of the products when a system is at equilibrium. So here we have a generic formula where the capital letters would be the compounds and the lowercase letters would be the coefficients in front of the compounds. So to write the equilibrium expression, KEQ is the equilibrium constant, and you would have the concentration of the products raised to the power of the coefficients divided by the concentration of the reactants, each raised to the power of the coefficients. The brackets around the capital letters indicate the equilibrium concentrations, so the units will be in moles per liter. So it's important to remember that when you are writing an equilibrium expression, only reactants and products that are either aqueous, dissolved in water, or gases should be included in the equilibrium expression. We don't include liquids and solids in the equilibrium expression. This is because concentrations have to go into the equilibrium expression that have the units of moles of solute per liters of solvent. A pure liquid or a pure solid does not have a concentration, so we don't include them. Gases are an exception here because their concentration can be found by dividing the amount of moles of gas by the amount of liters of the container, because gases expand to fill their container. So we can get a moles per liter concentration for gases. Okay, so now let's look at some specific examples of equilibrium expressions. So for the equation, 2 moles of O3 gas yields 3 moles of O2 gas. The equilibrium expression would be this. KEQ, which is the equilibrium constant, is equal to the concentration of the product, O2, the concentration of O2 to the third power, divided by the concentration of the reactant, so the concentration of O3 to the second power. Remember, your coefficients become the powers that they're raised to. So for the second equation, this would be the equilibrium constant. We would not include aluminum because it is a solid, and we would not include copper because it is a solid. So you would only have the concentration of AlCl3 raised to the second power divided by the concentration of CuCl2 raised to the third power. So now let's practice writing them. So we have the equilibrium constant, which is KEQ, equals the concentration of the products on top, so the concentration of NO to the second power, and we include NO because it is a gas, divided by the concentration of the reactants. Now we're going to include both reactants because they are both gases, so it will be the concentration of N2 times the concentration of O2. And since both coefficients are 1, they would be raised to the first power, which is the same thing as what the concentrations are. So that is our equilibrium expression for this reaction. Okay, the next reaction we have is this one. So only gases and aqueous solutions are going to be involved in the equilibrium expression. So since H2O is a liquid, we will not include it. So KEQ will be equal to the concentration of N2 divided by the concentration of the reactants. So the concentration of NO to the second power times the concentration of H2 to the second power. Okay, so now there may be some times when one side of the reactions has no gases or aqueous solution. So I want to show you what to do. So for that top reaction here, we would not include HBr because it's a liquid, so we would only include our reactants. So our equilibrium constant should have the concentration of the products on the top. But since we have no products to include here, you'll just write a 1 and then put the concentration of the reactants on the bottom. Okay, so for our second equation here, we would not include aluminum because it's a solid. We would not include HgCl2 because it's a liquid, and we would also not include Hg because it's a liquid. So our equilibrium constant would just be the concentration of AlCl3 raised to the second power. And there is no denominator here because our reactants would not be included. So that's the equilibrium expression for that reaction. So you have some practice to work on in your packets. Let me know if you need help.